enzyme screen now, guys, right?
Yep, see it.
All right, awesome. Awesome, awesome. All right, so what is an enzyme?
An enzyme is a catalyst for movement or process or something.
Technical terms, I love it. I do the same thing. Protein catalyst. You got the big word, right? It makes reactions happen. So, without enzymes, things don't function in the body, right? Um, and there's a few that we measure. Blood chemistry tests check enzyme activity. Um, so you want to, when we're talking about, what are we actually measuring in the blood? And it's the marker for enzyme activity. If it's low, right? If you have low enzyme, either there's not a lot of it being produced or it's not working properly. And we have to figure out where do we fall on the spectrum. And once again, we're never looking at a single marker. We want to understand what the marker is saying, but we want to understand, we don't want to just memorize a chart, right? And a lot of times in the Weatherby book, we skip over that first part that tells us what the marker is and go right to if it's low, it's X, Y, and Z, right? And if it's high, it's A, B, and C. And that's all we know. But you really need to understand, what is this enzyme doing? Why is it in the blood? And all of those things. So that's what we're going to get into. Um, so an enzyme um, enters the enzyme has these little receptors, right? And the substrate binds into the enzyme. The enzyme changes shape a little bit as the substrate binds. So then you have the enzyme substrate complex. They're connected. Um, then the enzyme does its job. It's either going to connect things together, right, in a reaction, right? There's reactions that build things and there's reactions that separate things. So very carefully, right? And this is from Khan Academy. If you guys don't know about Khan Academy, it's free. People actually use it to study for their MCATs, but they have a lot of videos and a lot of these diagrams that are really great. So if you really just want, if you're, someone that wants to watch the video, they have a lot of these. So, and then the products leave the active site of the enzyme. So this is breaking, this is a reaction where things are being separated. But we could just as easily say, turn the arrows in the other way and take the two things that are going to be joined into the complex, right? And then it releases them joined together. It does the same thing either way. So a coenzyme is an organic molecule that is necessary for an enzyme to function. They're usually found in water-soluble nutrients like B6 or B12. A cofactor is an inorganic molecule that is necessary for an enzyme to function. Metals like zinc or magnesium. So a lot of times we'll just say cofactor, and it's just generalized, but there are two different things based on whether it's an organic molecule or inorganic. And if you don't know what we mean by that, organic contains carbon and hydrogen. So if you took organic chemistry, it was all the carbon chained things. It uses covalent bonds. They look like these. They form rings. They form linear things. And then inorganic could be ionic or covalent bonds. There are no carbon hydrogen groups in inorganic molecules. So like sodium and chloride, which makes salt, is an inorganic compound. Cofactors, non-protein partners, iron, copper, zinc, magnesium, or calcium ions, they bind to an enzyme. That's what changes that shape, that allows that binding, that joining of the enzyme and the substrate together. And it's essential to function. So there's a lock and a key that happens, but without the cofactor, right? If the hand isn't there to put the key into the lock, they just sit there and they don't do anything. Coenzymes are the same way, but they're organic. They're derived from water-soluble vitamins, and they make the electrons move between the enzymes. So here's another visualization, right? You've got an inactive protein, you've got the cofactor, they come together. The cofactor binding activates the protein. And then the two substrates can come together. So without the cofactor, that enzyme, right? So this inactive protein is an enzyme, doesn't work.
So Joe, the cofactors, they are always minerals
No,
only? That's not true. Okay.
cofactor versus coenzyme, right? It could be. Um, but they're going to be the inorganic. So yeah, mostly you're thinking B6, magnesium, or you're not B6. You're thinking zinc, magnesium, iron, when all of those things come in, when you look at when we did methylation and we had all of those, it needs this and it needs this and it needs this for the enzyme to go from point A to point B, right? Um, that's what we're talking about. And genes code for enzymes, right? So
So it can be like
MTHFR,
B12, it can be B6, it can be some of those B vitamins also.
right?
I think I'm
And we,
seeing some drawings in that.
yeah. So and that's why we usually say cofactor, and it's just kind of like this all encompassing term for cofactors and coenzymes. It's just, this is a cofactor. Um, but there are technically, you would not get that correct on your biochemistry exam. It's probably fine for a chain at SAFM, but I mean, to understand that it's not going to work, right? Without this purple piece, this enzyme cannot bind whatever it's supposed to bind. You need the cofactor. It puts the two things together.
Hey, Joe,
Yeah.
this is a very basic question that I'm thinking my critical thinking should be able to answer it. But why in college are we started out with inorganic chemistry, like 3 or 4 quarters of it before you get into organic chemistry? What's the reason for doing it in that order? Is
I
there one?
think organic chemistry can be like once you start putting organic compounds together, even though there's only a few things that make up organic chemistry, I mean, some of these compounds are huge, right? And when you're looking at inorganic things, you're looking at these two things plus this makes this. It's very simple. You're not looking at
Uh-huh.
C24H32O16, right? And you're looking, it's just complicated.
So it's just
Inorganic chemistry is just here's salt and here's water and here's how it dissolves, right? And you
Mhm.
need those basics. So inorganic chemistry is much less complicated
Okay.
than
Thank you. Thank
organic
you.
chemistry. Um, so so without the coenzyme or the cofactor, the enzyme does not work. And this sentence is only true for 4 of these. Out of these 5, which one is not does not depend on a coenzyme or a cofactor? Does anyone know? Got a guess? You got a 20% chance.
I think,
Well, let's think
either
through it, okay?
GGT or the LDH, so I want to say well, I'm not
Well,
even sure.
when you look at a blood chemistry, what do we know? Which ones tell us if we have a deficiency? Like we know, oh, chat, I've got to pay attention. Uh,
Yeah, she says
she
GGT,
says
so
GGT. Okay, so we have a vote for GGT. Which one do we know we can cross off? It's one of the ones we say, oh, if this one's high or low, you're deficient in XYZ. So which one do we know we can cross off right off the bat?
AST, ALT, and ALP.
Yeah. So these 3 we can cross off right off the bat. We know that these are going to be dependent on. So now you've got a 50-50 shot, GGT or LDH.
So I'm not real familiar with LDH, but I know the GGT can
It's
tell us
lactose
about
dehydrogenase.
glutathione, can tell us about inflammation. Also, it's diabetes, but I don't remember that connection. So maybe I have to agree with Deb that it'd be GGT, not necessarily telling us something that's deficient, but maybe telling us something that's going on in the body. Well,
Are you second guessing yourself now?
I mean, if it tells us that if we're high or low on the glutathione, if I'm correct, is that, I mean, well,
Well,
again,
the
I just
answer is
don't like how
LDH.
bitch is. Okay.
The answer is LDH. But this is what I'm talking about, right? When you actually, we talked about it with the parroting, right? We learn so much, right? And I mean, it's good, right? We need to remember some of these things. I'd hate to have to look up absolutely everything every single time, but you get into the rut of, I'm just going to memorize these things. And I knew at one point why, but I couldn't tell you today why, right? So why is this B6 dependent? Why is this dependent on zinc? Why is it dependent on whatever? And how does that inform me? Well, so where else do I go to confirm my suspicion? Because that's what we need to know. We need to know enough about how these things function in the body that we know where else to look to confirm. Like, okay, is it magnesium or zinc? Which one? Or is it B6? Which one? Like, how does this function? So LDH is not dependent on a coenzyme or a cofactor. All the other ones are. Um,
What
enzymes
is LDH, Joe? Sorry.
lactose dehydrogenase. And we'll get into each one individually.
Oh, okay.
Um, so enzymes are found inside cells. The nucleus of a cell makes a needed enzyme. So there's always, right? When we talk about this with autoantibodies, right? There's always a certain amount of cellular breakdown. So, a lot of times things aren't going to be zero. Your body's going to have a certain amount of breaking down, of tissue degradation while we rebuild. So things need to get destroyed and made. So we expect to see enzymes in the blood, hence optimal ranges, right? So we're going to see optimal ranges. But when they're elevated, enzymes are seen on a when they're elevated, you can see that on a blood chemistry test. And you could consider that any elevation of an enzyme could mean increased cell breakdown. So tissue damage, inflammation, since these are intracellular, right? So they could be acting as, what are they called? Anybody? When things elevate in light of inflammation?
Oh, oh gosh, on the tip of my tongue.
Acute phase
It's like
reaction.
Acute phase reactant.
There you go.
Thank you.
Yes.
So it could be acting as an acute phase reactant. So ALT is found in the liver, right? AST is found in the heart, the liver, in the mitochondria, in muscles, lungs, kidney, brain, and intestines. What can we assume with elevations in AST but not ALT? If you've got an elevated AST but ALT is normal.
I used to know this stuff and I don't remember it, Joe, but I have one other question about the ALT and AST. Why did they, and I don't remember which one's which, why did they switch them from SGPT and SGOT to ALT and AST?
I have no idea.
Okay.
So on the AST and the ALT is more apt for liver, particularly where
Mhm.
AST is somewhere else. So could that be inflammation or things going somewhere else and not necessarily just the liver?
Correct. So when AST is elevated, you are definitely going to cross off this liver piece, right? If ALT is normal and only AST is elevated, then the liver is kind of out of, you can check that one off and start thinking it's definitely somewhere else. Whereas if they're both elevated, then you know the liver's involved too, right? So
Right. And I
So
see
just one of
that,
those things where when you start thinking about like, okay, I know this is somewhere else, but it's also in the liver, right? I mean, there are liver enzymes, right? It's just more apt. This is pinching my hair. Let me do this. I use glasses as a hair holder backer. Um, so right, they're all associated in the liver somehow, but AST is that somewhere else. GGT is kidney, liver, pancreas, intestines. The biliary tree and the lining is found specifically in the biliary tree and the lining of the bile ducts. ALP is liver, bone, placenta, and intestines. And LDH is everywhere. It's in all the cells, it's even in RBCs, and this is the one that's not nutrient dependent. So this is the little ALT for liver, right? And this is what Deb said, AST somewhere outside the liver. And then GGT is usually the gallbladder area and common bile duct. So for GGT, you need B6. It's located in the cell membrane. It helps get amino acids into the cell for glutathione, right? So you were right there, Julie. Glutamate, glycine, and cysteine, and it helps form glutathione. So GGT basically takes those three, separates them, puts them in the cell, and puts them back together. Make sure that they can fit through the cell membrane. ALT and AST both have B6 as a requirement. ALP uses zinc and magnesium almost equally. It's like 47 to 63 or 48 to 62 or something like that. It also needs vitamin C. And it functions best in an alkaline environment. So how do chloride, when you're looking at ALP, you also want to know how do chloride and CO2 look on the blood chemistry? For LDH, it's everywhere in all cells, once again, not nutrient dependent. So B6 is dependent on alkaline phosphatase. And alkaline phosphatase, the ring is able to remove the ring from B6 and allow it to get into the cell and then replace the ring. So there is this great slide here that shows that. So if you guys wanted to look at exactly how that happens, but you want to consider with alkaline phosphatase that if alkaline phosphatase is low, then you're going to have B6 is going to be an issue, right? That B6 is not going to be getting into the cell. Ah, I just got messed up. Sorry, guys. So there's different types of enzymes that are specific to plasma and have a functional role. So enzymes that are synthesized in the liver, but they're present in the blood in equal or higher concentrations than in tissues. So there's also lipoprotein lipases that work in lipid metabolism. There's proenzymes of blood coagulation, specifically thrombin and plasmin, and then pseudocholesterol. Say that one, right? 3 times fast. Pseudocholinesterase and butyrylcholinesterase and things like that. So there are also other enzymes in the plasma. Again, for all of these, without the coenzyme or cofactor, the enzymes don't work. And I'll fix that other slide so you can actually read it before I download it for you guys. So how does this affect our view of the tissue state? Could there still be liver damage while ALT is low? So what do you guys think? I don't want you to like just read the slide. So if you're looking at ALT and it's low, is there a scenario that you can think of where there could still possibly be some liver damage and things happening? I see all your brains working.
Could fatty liver be a problem?
How would that
Well,
impact?
I'm just thinking if that could be an issue, um, and your ALT would still be low. Is that probable?
Anything's possible, right? What would
True.
Put together the chain. Like how would that work? I mean, it happens in dehydration, right? You've got things that look normal,
Oh,
um,
that's true. Yeah.
right? Because dehydration is falsely elevating things or falsely, like you have scenarios where things get falsely pushed in one direction and then another dynamic is pushing things in the opposite direction. So,
I forget to go back to the basics and thinking more
well,
complex.
and
Yeah.
it's, yeah, I mean, and that's the thing. We have to think about all the scenarios. So you want to use ALT to determine what is happening with the liver, but is ALT going to function in the absence of B6?
No.
No. So you have two distinct different views of what's going on in the body, right? So you have to check, like, is this enzyme, right? Is ALP acting as an acute phase reactant, right? So if you're looking at elevated markers, ALP, it could be very high, right? And if ALP is super high, you can't use it then to assess whether zinc or magnesium or vitamin C is sufficient because we know then it's not acting in that way. The same way that you can't use ferritin to assess iron if ferritin is acting as an acute phase reactant, right? So if you have low alkaline phosphatase because you have a zinc or magnesium deficiency, but then you have tissue destruction pulling it into a normal range and nothing else. You look at nothing else is looking like ALP should be, right? Everything else in your being is looking at this going, this marker should not be okay, right? This should not be in a normal range, right? Because a lot of times that happens, right? We look at markers and you're like, it's okay, it's okay, it's okay, but it doesn't make sense. Everything you know about this client is screaming deficiency, is screaming inflammation, is screaming that these markers should be out of range, but they come back normal, normal, normal.
I've had that many times and I'm like, I don't know what to do. I'm like, why is they're deficient on everything else except then magnesium, they're fine. And I'm
Right,
like, wait, what? And
right. And
so
you're and then you have to start going, is this getting where it needs to go, or is it hanging out in the bloodstream? Right? Because it's the key, but the vehicle to put it in the lock isn't there. Right? It's the cofactor, but it's not getting where it needs to go. So it's usually a sign that there's some significant imbalance hiding because everything's skewed, so far off that it's hiding the deficiency. It's hiding the whatever it is.
so are
Um,
you saying the question would be they could be sufficient in the blood, which is what the blood tests are, which how much is in the blood, but may not be getting into the cell? Is that kind of what you're saying? Is that how we
mhm.
can think about that? Well, you're normal on magnesium, but we need to find out if it's going in the cell.
Right. I mean, how many times do you have people that have every single sign of magnesium deficiency?
Yes, exactly.
Right?
Yeah.
That was my guy, my crazy copper guy, right? Like everything's off, but his serum magnesium's spot on. I'm like, yeah, it's not right. You
I
know,
don't want to
like,
argue with it. And it's
and
like,
I'm like, oh, my first question is, are you supplementing with magnesium? And he's like, no, but he's supplementing with everything, right? I mean, like throwing everything but the kitchen sink at it, in an effort to try and push things, but his body's like overrun, right? Stop throwing things at me. I've got no place to put them, right? Everything's blocked, everything's, whatever, but we're still going to keep throwing stuff at it. And I mean, we do this with our clients all the time. Well, I'm deficient. Shouldn't I be supplementing with it? You said I was zinc deficient, so I started taking zinc. And you're like, oh God, please stop. Well, and that was the last blood test he got. His B12 was insanely high. And he's like, I decided to take some B12. Why? It was the only thing on your blood work that actually was, you had too much of. But let's supplement. Let's throw some more, fuel on the fire.
exactly.
So this was a question that came up, in light of all of this, for B6, how do we determine what somebody actually needs? And we can ask this of any single vitamin or mineral, right? How do we determine somebody's need? So if we were to pull a serum level of B6 and see it's elevated, once again, that's a clue. Maybe it's not getting in the cell. Um, and that's, maybe they're supplementing, right? And it's high in serum. So what are we supplementing for? Just to keep it floating around and not going where it needs to go. So there's a lot of investigation that you need to do about what's happening in the cell. What's its relationship to alkaline phosphatase? How does B6 get into the cell, right? And we know that it needs zinc to get into the cell. So if you're going to see a lot of, you see a lot of these different markers, and you decide it's a cellular issue, right? But then you look at ALP and it's 21, you need to start considering all the facts. What's going on behind the scenes? What could be happening? Um, right? So we don't have control over all of this, and there's a fork in the road, where this is where we've had all the clients, right? And they get these tests and they start going, oh my gosh, I need, this person needs this and they need this and they need this and they need this, right? And there's all these nutrient deficiencies. And most baby practitioners and people are just like, okay, so we're going to give them this supplement and this supplement and this supplement because they have all these holes we need to fill. But why are all those nutrients missing? Because we've all been there, right?
Gut problems, lack of
Yeah.
absorption. Either they're not eating it or they're eating it and it's not being absorbed, or their demand or lifestyle or their need for those nutrients outweighs what they're consuming.
Right. And we want to be able to fix it, right? We want to just be able to like spackle in all the holes. But if the foundational work isn't there, it's not going to help, right? Then we're going to have, those high serum B6 levels because, you know, we're like, oh, B6 is missing. This is the missing key. And so we give them B6 and they still just end up with high serum levels of B6 because we didn't go deep enough to figure out why. What is beneath all of it? Um, and when you find that missing piece, then you fix the function and then the deficiency isn't there. Um, So this was one of the tips that Brian Walsh gave in his when he was talking about these, and this is just one of those little tidbits to put on the back shelf. If you've got someone that has a 2-to-1 ratio of AST and ALT, it may be indicating that there's high levels of alcohol consumption going on their blood work. So um, it's not always that, but that could be one of the things. And he felt it was important enough to mention it. So Jen felt it was important enough to mention it. So I am mentioning it. Throw that one in your little toolbox. Um, so low LDH, it doesn't need cofactors, right? And it doesn't need coenzymes, and the body's not making as much. So what could be at play here? So LDH is related to carbohydrate metabolism. The enzyme is active in the presence of glycolysis. So you need, if it's low, then maybe someone just isn't eating the carbs, right? You need it for carbohydrate metabolism, but they're on a ketogenic diet, or they have good fatty acid metabolism. So they don't need, they're not processing the sugars as much. It could be that they have hypoglycemia, right? And then this is going to run low. It could also be the opposite, right? You could have insulin resistance and diabetes, and the glucose is not going into the cell. Therefore, you don't need the enzyme to break down the glucose because it's not where it's being broken down. Or they could just be straight up mitochondrial dysfunction happening. So ALP is found in endothelial cells of the liver lobule canaliculi. It's a big word, but this is inside the liver. That's what they look like, these little octagon um, groupings of cells. And you've got the different blood supplies and you've got the bile ducts, and this is blown up. So this is the bile duct, and these little tiny star looking things are the bile canaliculi, and that's where ALP is formed and found, in those little star bursts in the liver. So it's not a marker where you can claim outright liver dysfunction when you're talking about it. So this is a little chart, just, for when you're looking at these enzymes and when they're high or when they're low and things you might consider. So ALT, these are the things that you can consider: B6 deficiency, liver congestion, protein deficiency, and malabsorption. AST being low, once again, B6 dependent, protein deficiency or malabsorption. GGT, also dependent on B6, protein deficiency, malabsorption, and magnesium. ALP could be zinc, could be magnesium, could be vitamin C, or it could be in hypochlorhydria. LDH, the same things that we just had on that previous slide. These are the things that could be happening if it's high. Walsh had said intestinal permeability comes up again and again with high ALP, but I know Jen looked into it, and Walsh had said he can't find good data to back that up. And so it's here, but it's got a question mark only because it's mentioned again and again. So if you guys find something that actually confirms that, let me know.
This is a nice chart.
But the thing is, you want to remember, right? Like, you want to be able to think through these things for your clients. So once again, I've got that slide again, and that's the end of the slideshow. What I did find, and I said in the beginning, I don't know if you guys were all on, this one guy, first I want to grab this link for you guys. Let me go back to that one. All right,